Hi everybody, welcome to the first lesson on hypothesis testing. This is the first of several we'll have on hypothesis testing over the next few weeks. We're going to be doing a whole lot of hypothesis testing. So what we're doing in today's lesson is a really key concept that we'll be revisiting pretty much every day for the next few weeks. It also is one that this material takes a little bit of extra practice to master, which is why we're spreading out some of these sections over 2 days. So because this takes a little extra practice and it's such a key concept, now's a really good time to put that extra effort in to making sure you can do this. And you've got this material down before we continue. So, big picture with a hypothesis test, we have information in a sample, and we have some hypothesis about the population. And we'd like to be able to say, based on what I see in the sample, that's strong enough evidence to conclude what I want to conclude in the population. For example, here's one problem that, not today, but by the end of the lesson Thursday, that we'll be able to answer. So here we've got a random sample of pizza deliveries from a company that claims to deliver in under 30 minutes. And based on that sample of 50 pizza deliveries, the mean is 28 minutes. And we have a standard deviation. So based on all of this information in the standard deviation, we want to know in the population, can we conclude that the mean delivery time is under 30 minutes? All right, so we know it is in the sample. The sample is 28 minutes. But the question is that enough to say that in the population, the mean is under 30 minutes? So hypothesis testing is essentially a formal argument. And the structure of it is that we want to find evidence that a hypothesis is true, such as that a company delivers in under 30 minutes on average. So what we're going to do is we're going to assume that that's false. And we're going to show that this opposite is unlikely. So for this example, we're going to end up saying, okay, well, suppose they don't deliver in under 30 minutes on average. Based on this evidence, we're going to try to show that it's unlikely that they don't deliver in under 30 minutes on average. I realize that's kind of a convoluted argument where we're assuming the opposite and trying to show that the opposite is false. But that's the way this works. I didn't create it. You can blame, I believe, Sir Ronald Fisher for that. So every hypothesis test has two hypotheses. And I'm going to start by talking about the alternative hypothesis, which is labeled HA or H1. And by the way, HA and H1 completely equivalent to each other. It does not matter which one you use. You'll see me use both at different times. And there's not any logic or reason behind why I would choose one or the other in a given moment. So the alternative hypothesis, this is the hypothesis that you're looking to demonstrate. Okay? This is the one you hope is true. Or in this case, the pizza delivery company hopes is true. The null hypothesis, on the other hand, this is the opposite of that. This is the, where we said we're going to assume the opposite. That's what the null hypothesis is. It's that opposite thing that we have to assume is true unless we find enough evidence to conclude otherwise. So the null hypothesis is called H naught. H with a subscript of 0. That's not an O, that's a 0. And that's not as in nothing. So essentially, this is the hypothesis of no information. This doesn't really mean anything except it's that opposite thing that we have to assume. Whereas the alternative hypothesis is the one we're hoping to support. The alternative hypothesis, you can also think of it as the hypothesis that there is something meaningful in the data. Later on, this will be that there's a difference between two means, or that there's a relationship between two variables. So we're always looking to support the alternative hypothesis. And I'll point out here, you see how I took this word prove and struck through it? That's because we can't ever prove anything conclusively using statistics. So take that word out of your vocabulary toward this course, because we can't ever say anything conclusively here. We always have to leave ourselves some room for error, some room for doubt. So, the question is not can we prove something is true, but can we conclude it? Is there enough evidence to support this conclusion? But we can't ever say anything unequivocally. Hypothesis testing was actually modeled on the criminal justice system in the United States. And in that model, we've got two hypotheses. We say that a person is innocent until proven guilty. We're not saying prove, but essentially that's what's going on here. So we have two hypotheses. Our alternative hypothesis, that's that thing we're hoping to test. Okay, this is the thing that the prosecution anyway is hoping to demonstrate that the person is guilty. The null hypothesis is that the person is innocent. This is where we're saying, okay, I'm going to assume the opposite. Okay, so this is H naught unless, not proven HA, but it's H naught unless there's enough evidence to conclude HA. All right, so the null hypothesis is innocent because that's just what we're assuming, unless we have enough evidence to show guilt, which is, that's kind of the point of a criminal justice trial, is to try to prove the person guilty. There are, in the criminal justice model, there are two possible conclusions to a hypothesis test, or to a trial. The person could be found guilty, or the person could be found innocent. And I'm going to introduce language to you here that you probably wouldn't hear in a court case, but this kind of language is what we're going to be needing to use. So there's two parts to any conclusion of a hypothesis test, and we're gonna state those in these words. We start with if the person is found guilty. We would say, okay, I reject H naught, which means there's enough evidence that I don't believe H naught. I have found enough evidence instead favoring HA. And the way we would say that formally is reject H naught. There is sufficient evidence to conclude that the defendant is guilty. Okay, so we're starting with this assumption of H naught, and we're able to say, yeah, we're able to rule that out almost completely and say we found enough evidence that the person is guilty. So this is one possible conclusion. The other one, you know how we said there were kind of double negatives, and we see that here. And this just takes a little bit of getting used to. If we find the defendant not guilty, the way we would have to phrase that is saying fail to reject H naught. There is not sufficient evidence to conclude that the person is guilty. So with this one, we're starting with this assumption of H naught, as always. But in this case, we say, no, I'm stuck at H naught. I can't rule that out to conclude that the person is guilty. So there's not sufficient evidence to conclude that the defendant is guilty. Okay? And these are the only two possible conclusions. There's no mixing and matching on these two sentences here. All right? And I put a meme here. This is the first of a few. And they're silly, but I'm hoping that the memes kind of help you remember some of this. So you don't ever accept a null hypothesis. And this is actually something that I think I've seen in your book where they actually do that, and that's the only textbook I have ever seen where they use that language. But even if you see it in your textbook, still do not ever accept a null hypothesis. So instead of accepting a null hypothesis, we fail to reject it. So there are 4 steps in hypothesis testing. The first one, and we're going to go through each one of these in great detail. In today's lessons, we're going to look pretty closely at steps 1 and 4. And then in the next class, we're going to look at steps 2 and 3. We'll do a little bit of 2 and 3 today. So you have to first set up the hypotheses. Mean determine what is your null hypothesis and what is your alternative hypothesis. So we've seen a little bit of that already. We'll get lots of practice with it. The next step is to calculate the test statistic and the p-value. And I know you don't know what those are yet, but you will. Those are essentially the evidence in your trial. Step 3 is to state the rejection rule. And that step is going to be just a matter of writing down the same thing over and over again. So every problem is basically going to have the same rejection rule. The rejection rule is kind of like your standard of evidence. Like you have to have proof beyond all reasonable doubt, they'll say in court cases, or beyond a shadow of a doubt, or proof by preponderance of the evidence. That's the rejection rule. And then the conclusion, in the words of the problem, that's the verdict. So that's essentially the steps of hypothesis testing. You're going to go through every one of these for every hypothesis test you do. So starting with the first hypothesis test we're going to be doing, which is the one sample Z test. We're going to be testing about the population mean. So for the one sample Z test, there's 3 possible sets of hypotheses. And for all of these, we've got this symbol mu naught, which means this is just a hypothesized value for mu. Okay? So for the alternative hypothesis, we could be looking to test whether mu is less than some given value, whether mu is greater than some given value, or whether mu is not equal to some given value. So those are all our 3 possible alternative hypotheses. Now for the null hypothesis, if you notice here, the opposite of not equal to is equal to. So that's our null hypothesis there. For the other ones, this may at first seem odd to you that both of these are equals. But let me just say to start with that the opposite of mu greater than mu naught is mu less than or equal to mu naught. So you may see this null hypothesis as less than or equal to. For this one, the opposite of less than is greater than or equal to. So you may see it like that. But a lot of people, a lot of textbooks, just go ahead and put equal to for reasons that there's a reason that we'll see next time, but also we're never concluding the null hypothesis anyway. So for now, let's just think of it as we're not concluding the null hypothesis anyway, so it doesn't really matter. These first 2 problems, or these first 2 alternative hypotheses, are called one-tailed tests. And it's a one-tailed test if your alternative hypothesis is less than or greater than. It's a two-tailed test if your alternative hypothesis is not equal to. All right? And this one here, the less than is sometimes called a lower-tailed test, and the greater than one is sometimes called an upper-tailed test. So that's just some terminology. So let's get some practice setting up these hypotheses. So for the first one, an economist wants to know if the average price of a 20-inch flat-screen TV has decreased since 2002 when it was $530. Well, I always set up my alternative hypothesis first. So the thing we're looking to test is whether the mean has decreased. In other words, whether mu is less than what it used to be, which is $530. So our alternative hypothesis is going to be mu less than 530, and that's because of this word decreased. Okay, decreased means it has gone down. The null hypothesis is going to be essentially the opposite of that, which is mu equals 530. And if you'd rather write this as mu greater than or equal to 530, that's fine too. I certainly wouldn't count off for that. All right, the important part is that you've got the alternative hypothesis is mu less than 530. This value here, the hypothesized value, will be the same on both of these, and this should be either mu equals or mu greater than or equal to for this case. All right, so how about you try the next 2. Pause the video and I'll give you a minute to try those. So let's look at the second one now. So on this one, we're looking to test whether the tomato plants are producing more than 20 tomatoes per season. So this means this is going to be our alternative hypothesis, whether mu, the population mean, is more than 20. So this is going to be our alternative hypothesis, and that means our null hypothesis is going to be mu equals 20. Or you could say less than or equal to 20, and that would be fine too. All right. Now we talk about, I talk about the alternative hypotheses first, but you still need to list your null hypothesis first, just because of the logical nature of the argument is that you start with the thing you're assuming. In this last example, a criminologist is interested in whether the average sentence has changed since 1990, when it was 90 days. This word changed implies that it could be greater than or less than. So this is going to be a two-tailed test, meaning our alternative hypothesis is going to be not equal to. So our hypotheses here, our null hypothesis is going to be that mu equals 90, and our alternative hypothesis is not equal to. Okay? All right, so now let's talk about the possible conclusions to a hypothesis test. And we mentioned this before with the court case, but let's look at it in terms of statistics as well. So there's two possible conclusions to every hypothesis test. You can reject H0 or you can fail to reject H0. Every time you reject H0, there's a sentence that you need to state with that. And then there's another one if you fail to reject H0. And I'm going to tell you, I've got this written in very general terms here, so you're not going to use this in, you're not going to use this verbatim. So if you reject H0, that means that there is sufficient evidence to conclude whatever your alternative hypothesis says. Okay? But you're not going to say that verbatim. Okay? You're going to actually state it in the words of the problem. Okay? So reject H0, there is sufficient evidence to conclude, and then you're going to fill in with what you're looking to prove, demonstrate in that problem. The other possible conclusion is that we fail to reject H0. If we fail to reject H0, that tells us that there is insufficient evidence to conclude that thing we were looking to demonstrate statistically. Okay? So let's go through our examples and state the possible conclusions that we have. So for our first example, we had a null hypothesis of mu equals 530 and an alternative hypothesis of mu less than 530. If we reject H0, that tells us that there is sufficient evidence to conclude that the population mean is less than 530. All right? Now, if we fail to reject H0, then that just tells us that there's not sufficient evidence to conclude that the mean is in the population is less than 530. All right? So these are the only two possible conclusions, but they have to be written pretty much exactly like this. Okay? Acceptable variations are, reject H0, we can conclude. Or fail to reject H0, we cannot conclude. Or reject H naught, the data supports the population mean. Or fail to reject H naught, the data does not support this conclusion. But regardless, it's got to be written almost exactly like this. Our second example, we said a farmer trying to decide to use whether the same brand of tomato plant. We had a null hypothesis of mu equals 20, an alternative hypothesis of mu greater than 20. Our first possible conclusion would be if we reject H naught, that tells us that there is sufficient evidence to conclude that mu is greater than 20. So reject H naught, there is sufficient evidence to conclude that the mean yield for each plant is greater than 20 tomatoes. And keep in mind, this is for the population. We know what the sample mean is because we collected it from a sample. And we calculated our mean there. We know what the sample mean is. The other possibility is that we fail to reject H naught and say there is not sufficient evidence to conclude that the population mean is greater than 20. Our final example is that a criminologist interested in whether the average sentence for repeat drunk drivers has changed. We had mu equals 90 as our null hypothesis and mu not equal 90 as our alternative hypothesis. If we reject H naught, that means that there is sufficient evidence to conclude that mu equals 90. And if we fail to reject H naught, that means that there is not sufficient evidence to conclude that mu differs from 90. All right? So for now, I just want you to get practice at setting up the hypotheses and stating the possible conclusions. That's it for this lesson. And, as always, I hope that you will let me know what questions you have.